So as I said when I was passing out the outline, this is our last, this is day 5. We've been spending this whole week reviewing linear equations. Okay, so it's been like algebra review, and we're talking about slope and the relationship of slopes for parallel and perpendicular lines. So this is 3.5. Load, there we go. All right, so the steps for writing equations of lines that are parallel or perpendicular to a given line, okay? So first, whatever equation you're given, if it's not in slope-intercept form, y equals mx plus b form, we need to get it there so we can identify the slope. So if you have forgotten, if you don't know the names, slope-intercept form, the y, is y equals mx plus b. So we got to get it in y equals mx plus b form so we can identify the slope. Once we have identified the slope, then we can use that slope to determine our new slope, whether it's the parallel or perpendicular, depending on what we're asked to do. Okay. Is the wording just a little different?
Wait.
Well, we don't. It's just like.
Oh, it's not and identify the slope.
It says change the standard form to slope-intercept.
Okay, so you can just add and identify the slope. If there's something a little off, you can add to it. Okay, but the reason we're changing to slope-intercept form is so that we can see the slope. Okay, that M right there, that's what we're looking for. Does that make sense? Okay, so we get the given equation to slope-intercept so we can see the slope. Then using that slope, we determine the new slope, whether it's parallel or perpendicular. What does parallel mean? Same slope. What does perpendicular mean? The opposite reciprocal. Okay, so depending on what you're asked to do, you'll do one of those two things and you'll have the slope for the line you're trying to write. Okay, so then you use your new slope and you use the point that you're given. Okay, and you write point slope form, which we did, I think that was yesterday. We were focusing on point slope form. That's the y minus y1 equals m times x minus x1. Okay. Then, depending on what you're asked, you can then rewrite that to slope-intercept form. Once you plug in your point and your slopes, then you can go back, you'll plug in here, here, and here, and then you can rearrange and solve for y if you need to. Okay, so we're going to on today's notes, but depending on your practice or the question, if it doesn't tell you to give your final answer in slope-intercept, you can just leave it in point slope form. That's okay. All right, everybody good with the process, what we're going to do?
Yep.
All right, let's do it. For the first one, it says write the equation of a line that goes through the point 2,5 and is perpendicular to the line negative x plus 4y equals 6. So I need to take this given equation and get it in y equals. So I'm going to add x to the other side. Of course, my pen stopped working. There we go. I cannot combine the 6 and x because one's an x term, one is not. So I'm just going to have a positive x and plus 6. Okay, so then once I do that, how do I get rid of the x, or excuse me, the 4?
Divided.
So divide out the 4. What you do to one side, you do to the other. All right, so I can leave this written this way, but it's not really slope-intercept form. What's understood in front of that 1 right now? I said in front of the 1. In front of the x is an understood 1. Okay, right? So this would be 1 over 4. So we would have 1 over 4x. And then 6 over 4 would reduce to 3/2. Not that we don't really, at this point, we don't need the intercept the 3/2, so it doesn't really matter. What we really need is the slope. Okay, so you can go through this whole process, get it in y equals, because now we see our slope of the given line. Okay, so the slope of the given line is what? 1/4. So now we want to find, they told us here to get the perpendicular. Okay, and perpendicular means opposite reciprocal. So my perpendicular slope would be what?
-4.
-4. Y'all agree?
Yes.
Okay, so now that is my slope that I'm going to use to write my equation. I have the points that they gave me, and I have my new slope. So I'm going to plug those in. So y minus y1 equals m times x minus x1. So the slope is -4, and the ordered pair, the y is 5, the x is 2. And now they did tell us here in step 4 to rewrite it to slope intercept. So I am going to go ahead and solve this now. So then I would distribute. And then I would have to move the 5 by addition. So I end up with y equals -4x plus 13. Now, I could check this when I'm practicing with Desmos graphing. You're not going to have Desmos graphing on the test, but for while you're getting the hang of this or refreshing on it, you could plug in the original and plug in what you got, and you could see a visual. Are they perpendicular? Okay. Does this line cross through the 0.25? So you could check this using your graphing Desmos, right? If you wanted to. All right, now you can do this every single time, what we did here in red, okay? Or you can understand that when you're going from standard form, where you have ax plus by equals c, some of you can get the slope quicker without converting the entire equation. And that's okay, because all we need is the slope from that original equation. So if you understand that you're moving your x term to the other side, right? So what is that -2x going to become on the other side? It'll become +2x, right? So +2x. And if you need to write the whole thing, you can. But some of you in your head are just going to be like, okay, that'll be +2x. And then if there's a coefficient in front of y here, you would divide it out. There's not, so I'm done. So what's my slope? 2. But if there was a number there, like, so for this one, to move that x, I would have to subtract it. So I'd have -1x, and then I'd divide by -4. So that would be +1/4. Y'all agree? So I just found that slope for number 3 without writing anything down, without actually converting the entire equation. If that is possible for you, if not everybody can do that. Some people need to write it down. They don't know what I just talked about. And that's fine. You can do this work every time. But it's okay if you can move. You're moving the x by opposite. So it's going to be the opposite of your a divided by b. This is ax plus by, right? So if you can just identify in standard form your a and your b, it's just going to be -a over b. That's your slope. Are y'all following me? Okay, so I'm just giving that as an option instead of doing this work every single time. Some of you can just do that -a over b, -a over b, -a over b, and get your slope. Okay, yeah. All right, so here we've got my point that I want to go through is 2, 6. This time they want a parallel line. So parallel means what? Same slope. So the slope that I'm going to use is going to be 2. So now I've got my slope and my point to plug in. So y minus y1 equals m times x minus x1. So the slope is 2, and the point, the 6 is the y, and the 2 is the x. And then I'm going to distribute my slope. And then I'm going to move my constant. And then if I wanted to, I could check that in Desmos. All right, we're feeling okay about that process? All right, so what I said over here for my slope is if I am in AX plus BY, if you want to add this like at the top or on the back or somewhere, if I'm going from standard form, I can quickly identify the slope. It's going to be the opposite of A, so negative A divided by B. So if you want to do that to have quicker work than converting the whole equation, you can do that. Okay, so to identify the slope from standard form, you can just do negative A over B. So negative A is -1 and B is -4. So that comes out to 1/4. Y'all agree? Okay, so if you want to do it this way, it may be a little quicker. Now they're asking us to write an equation that is perpendicular to that line. So perpendicular means my slope should be opposite reciprocal. So it should be -4. Are we so far so good? Now I want to go through the point 3, 1. My slope is -4. The X is 3, the Y is 1. Then I distribute. I've got -4x plus 12. And I'm going to add the 1 over. And I can check that in Desmos. Any questions so far? Okay, so I'm going to do the same thing here on these bottom 3. Let me go through and just practice doing that negative A over B to get the slope of the given line. Okay, so the slope of my given line is going to be, right now, A is -1. Do y'all agree? In front of X, that's a -1.
Yes.
So the opposite is going to be +1 divided by B, which is 5. So that's the slope of that line. Y'all understand that? Without having to convert the whole equation, I can just do negative A over B. Okay, so what about here in number 5? The opposite of 6 is -6, and then I have to divide, which is the B is -1, so that comes out to +6. Okay, so here the opposite of A would be -6 divided by B, which is 2, so that would be -3. Okay, so do we feel okay about identifying the slope from standard form without having to convert the whole equation? Okay. So now I'm going to look at what I'm trying to find, which for this one is parallel, perpendicular. All right, so my parallel slope, parallel means same slope, so it's 1/5. So parallel slope here will be 6. Perpendicular slope means opposite reciprocal. So the opposite is going to be positive and the reciprocal will be 1/3. So now I've identified my slope that I need for each of these. So now I'm going to fill in I don't know why I just wrote an equal right there. Y minus. All right, so for number 4, my slope is 1/5. My point is x is 0, y is -2. And actually, what kind of point is that? Yeah, if x is 0, that's a special point. Somebody said it. Y-intercept. Okay, so couldn't I jump straight to slope-intercept form? So if you realize that you have the y-intercept, you can jump straight to slope-intercept form. Because you have the slope and you have the y-intercept. Okay, so you can jump straight to that. Now, if you didn't realize that and you did this work over here, wouldn't it come out the same?
Yes.
Yeah, so it's okay if you did all this plugging in and you solved, it's going to work out the same. No worries. All right, so what type of point over here? Now that's inverted, -2, 0. That is not a y-intercept. That's an x-intercept. So that's not my b. I'm going to just plug in like normal. Okay, so my slope is 6. My y is 0. My x is -2. So now -0, that leaves y alone. So I don't have to move that constant. Come on, Ben. I just need to simplify. That's going to be a plus. And then I need to distribute that 6. So that's going to be 6x plus 12. All right, so then over here, my slope that I need is 1/3. The y is 5 and the x is 3. So I'm going to distribute my slope. Okay, and then move my constant. And again, all of these can be checked. If you're getting something wrong when you're doing your practice and you're like, I don't know what I did wrong, go look at the graph in Desmos if you need to. And you should be able to see if the lines are parallel or perpendicular, and you should be able to see if it goes through the point that they want it to go through. Any questions? Okay, so your practice is in, I think I didn't link it on the calendar, but it should already, you should see it in the assignment list or in the module. I'll link it in the calendar right now. All right, it's linked in the calendar now as well, so you can look to your practice from the calendar, the assignment list, the module, the to-do list. Okay, everybody should be practicing.